In the great dark beyond the orbit of the outermost worlds, where the sun's warmth thins into a pale whisper and the black of interstellar night presses close, a traveler appears. It is small against the scale of space, so small that at first it is nothing but a needle scratch of light on a deep, infinite vellum. Yet that thin signature carries a revelation. The path is wrong for anything born here. Its speed is wrong, its angle is wrong, its origin is elsewhere. This is not a child of our sun. It comes from away. For most who watch the sky, such a visitor is a wonder and then a footnote. But to those who map trajectories and weigh light, this one is a problem wrapped as a gift. It brightens as it falls inward toward the star, as expected of icy bodies that warm, vent gas, and throw off dust. But the brightening is sharper than usual, the color trending strangely, the curve not quite matching the easy patterns. And then comes the shift. No flash, no explosion, no spectacle, only a quiet disobedience of gravity's script. The object's position drifts from the forecast line, minute by minute, night by night. When the numbers are stacked and error bars tamed, the verdict is plain. There is non-gravitational acceleration nudging this wanderer along. Gravity is the metronome of the cosmos. With it, you can calculate the fall of an apple and the arc of a comet and the looping ballet of planets around their hearth of fire. If you know mass and distance and motion, you can predict a path to ruthless precision. But the visitor refuses to be governed by gravity alone. A subtle push exists, continuous, directional, consistent enough to move predictions away from reality. Something else is at work. There is a natural explanation that often fits. Sunlight heats fresh arriving ice. Jets of gas erupt from fissures and vents. The escaping material produces a tiny recoil, the way air hissing from a valve inches a balloon across a table. Over days and weeks, that gentle recoil can matter. We have seen it before in the classical comets of our own cloud. Activity increases as they draw near the sun, and the non-gravitational term folds into the model, and the path is reconciled. But with this interstellar traveler, the magnitude of the effect implies a cost, a very large cost. If outgassing is to blame, then the object must have shed an enormous fraction of itself as vapor and dust. Momentum conservation demands it. To get that push, so much mass must be flung one way that the remaining body is bucked the other. Such an event should not be subtle. There should be a cowl of gas, a fog of particles, a swelling veil bright enough to announce itself in even modest instruments. By now, if that recoil explanation is right, the visitor should be wrapped in an expanding, shimmering shroud. And in science, the missing thing can be louder than what is present. The absence of an expected halo is not merely a curiosity, it is a tension that tugs at all subsequent conclusions. If the object is venting at the required rate, where is the proof of that loss? If it is not venting at that rate, what then is doing the pushing? Another puzzle object once wandered through these precincts, also a foreigner, also a breaker of assumptions, also accompanied by that gently impudent acceleration. That earlier visitor left no obvious tail, shed no easy cloud, kept its secrets in geometry and reflection. Theories multiplied. Perhaps it was a porous fractal of ice. Perhaps it was a thin sheet, like a cosmic leaf. Perhaps it was a brittle shard with an albedo that mocked our priors. All were mechanisms to generate a push without the expected plume. Our current visitor opens the case again. It arrived from a direction that hangs, as so much does, over the central band of the Milky Way, rich star fields, heavy dust lanes, a nimbus of unresolved light. That detail, while dramatic for painters and poets, is likely coincidence. Objects fall to us from wherever their long paths lead. But it colors the imagination, because the galactic center is a place of mass and mystery, of deep wells and tight orbits, and radiation that hums with old stories. Into that backdrop, the visitor writes its thin blue-white line and dives toward our star. As it approaches perihelion, closest brush to the light, the object changes in measurable ways. At great distance, a whisper of gas may be detectable in specialized instruments, the suggestion that some volatiles are present, some molecules leaving the surface, some crystalline structures reorganizing under heat. But hints are not verdicts. What matters is what happens at and after the turn around the sun. If the non-gravitational term arises from furious venting, then once the object rounds the glare and slides back into darker skies, a colossal envelope of material should frame it, glowing, scattering, revealing. If that envelope is not there, we must search elsewhere for answers. And there are other elsewheres. One possibility is pressure from light itself. Photons carry momentum, reflect them from a surface, and a force, tiny but persistent, acts upon that surface. In sails and foils and hollows, the pressure of sunlight is enough to sculpt an orbit, to alter a path, especially if the object is thin, highly reflective, or of an unusually low mass-to-area ratio. The mechanism needs no venting cloud, no glow of gas. It needs only the right shape and the right surface properties. If the visitor is a natural artifact that happens to be a fragile sheet or a brittle lattice, a flake from the skin of a larger thing, it might ride the sunshine with negligible shedding. If it is not natural, if it is manufactured, the same principle holds, though that explanation must be earned by evidence, not borrowed for spectacle. Another possibility, deeply buried volatiles sublimating in a way that is anisotropic but stealthy, molecules escaping through pores so fine that little dust is lofted, gas dispersing before a coherent coma can form, jets that are more like an exhalation through felt than a spray through a nozzle. In such a case, the recoil could be sizable, while the visible signature remains frustratingly modest. The numbers would still require substantial mass loss. The optics might still refuse to cooperate. A third possibility, we misunderstand the size, density, or shape. If the body is larger than assumed, the same push requires more outgassing. If smaller or less dense, less. If its rotation tumbles certain faces into and out of sunlight, if cavities act as temporary traps and sudden vents, the effective acceleration could be episodic, averaged into a steady term. Uncertainties in albedo, shape, and spin can shift the parameter space in surprising ways. We will not settle those possibilities while the object is in the sun's glare. For the moment, the visitor glides through the most unforgiving backlight in the solar system. Thermal instruments at different vantage points strain to capture its outline. Data pipelines fill with raw numbers that mean little until calibration and context do their slow, careful work. Meanwhile, models run. They project trajectories with and without the non-gravitational term. They propagate uncertainties. They test scenarios. The sky is patient, the math is patient, the observers learn to be. Soon, days, then a handful of weeks, the geometry improves. The object will climb into dark skies again, accessible to the keenest mirrors on and above the Earth. Then comes the decisive test. Is there a luminous envelope? Is there a tail? How do the spectra break? Does the light curve wobble with a rotational period? Do polarimetric signatures hint at dust grains or smooth surfaces? Each question points to composition, to structure, to the physics of the force that will not admit its name. Where the visitor goes next may be mundane or momentous. The sensible default is simple. It will continue along a hyperbolic track and exit as it entered, a ghost crossing the threshold of our star's dominion, a line drawn and then erased by time. But celestial mechanics affords a special trick near deep gravity wells. If an object can provide its own impulse near perihelion, if it can burn when it is moving fastest, it harvests more change in trajectory per unit of propellant. This is the Oberth effect, a plain truth of orbits that spacecraft engineers cherish. For a natural body, it has no meaning, unless the body somehow is capable of thrust. Minds leap at that conjunction of ideas and ask what they always ask: could it be intention? Yet caution is the adult voice in the room. Extraordinary claims demand ordinary, plodding, patient proofs. A course change is something you can measure, an anomalous acceleration you can fit, an absence of coma you can document. A story about agency is not the next step. The next step is to look again and again and again until the measurements corner the behavior and the explanation has no room to wriggle. Even if the path is purely natural, the visitor's timing is interesting. In the early days of the coming year, the inner planets will arrange themselves into a near line with the Sun, while one of the great outer worlds, massive and magnetic, takes its place roughly along the same axis. The alignment will not be exact, celestial alignments rarely are, but it will be close enough to raise old questions about resonances and fields and the layered, breathing weather of the heliosphere. During that window, the visitor will be out from the glare, on display among these shifting relationships. It is fashionable to dismiss alignments as theater only. Certainly, the gravitational pulls that planets exert upon one another are minuscule at these ranges. You cannot shove a world with a whisper. But the Sun is not merely a ball of gas. It is a dynamo of fields and plasma, a roiling, convecting engine braided with magnetism. When large bodies occupy certain long lines through that environment, the flows can organize in ways we do not yet fully quantify. The result is not a tug on the Earth you would feel in your bones. It is an alteration in the great weather of space, where charged particles stream, where magnetic ropes snap, where shocks race ahead of coronal bursts. In such times, the solar wind may shift, the aurora may creep lower, the skin of our world may crackle with the faintest trace of distant storms. If we are attentive during that period, we can learn how the presence of a foreign object responds to the Sun's pulse. Does its brightness modulate with solar output? Do charged dust grains around it align differently when the interplanetary field swings? Do radio quiets deepen or lift? These are not romantic questions. They are measurements, and they breed understanding. For all the talk of affect and omen, the visitor is a material thing. It has a surface temperature and a rotation state and a set of compounds bound into its crust. It has a tensile strength that limits how it can fracture and a porosity that governs how heat penetrates. If it is natural, its current behavior was programmed by the way it formed around another star, by collisions it survived, by eons drifting in the cold, until this meeting with our light. If it is unnatural, if it is an artifact, then there are other stories to tell, stories that expand the perimeter of the possible so far that our language must widen to contain it. But nature is cunning enough to explain surprises in most cases. Exotic ice mixtures can sublimate at temperatures and rates that shock intuition. Dust grains can be small enough to escape quickly, leaving little optical trace. Microjets can operate like tiny thrusters without raising a cloud bright enough to impress. Shapes can be deceiving. Our reconstructions from light curves are inversions that can admit multiple solutions. Our certainty must remain provisional, confident in method, humble in the face of what we might be missing. We will know more when the visitor comes out of the Sun. When that happens, a choreography begins. Wide-field surveys germinate the first detections in the post-perihelion sky. Larger apertures take the baton, carving spectra into their constituent lines, chasing the fingerprints of gas species, hunting for the broad wings that betray dust. Interferometers probe for extension. Are we looking at a point or at a thing with breath? Time series photometry watches for periodic flickers. A rotation period means facets, silhouettes, albedo patches sliding through view. Thermal infrared arrays estimate size from heat, cross-checking against optical brightness to infer reflectivity. Polarimeters test for grain size and roughness. Each instrument speaks a dialect. Together, they write a report. And there is geometry to exploit. As the Earth moves along its orbit, the line of sight to the object changes. Parallax shifts. Phase angles open and close. And with those angles come opportunities. Forward scattered light that brightens fine dust disproportionately. Backscattered regimes that prefer larger grains. Half-phase conditions that reveal surface microtexture. In some geometries, flat reflective surfaces flash, specular glints that, if seen, would be seismic for interpretation. In others, nothing much happens beyond the slow dimming that attends distance. We take what the heavens give and squeeze it for signal. There is also the question of mass. We seldom weigh a solitary rock in space directly, but we can constrain. If the object is small and reflective, a modest cross-section can yield the observed brightness. If it is large and dark, the same brightness demands a bigger body. Combine that with thermal measurements and you start to triangulate. If you can measure acceleration from non-gravitational effects and you have an estimate of area, you can back out an effective mass-to-area ratio, which is a powerful discriminant among hypotheses. A fragile flake of porous ice may have a very low ratio. A dense metallic shard would have a much higher one. Numbers discipline imagination. And still, there is room for wonder, because interstellar objects are time capsules. They bottle the chemistry of other cradles of planets. They may carry isotopic fingerprints that differ from ours, clues to the mix of elements in a nursery cloud we will never visit. They may be crusts from the faces of unknown giants, or gravel from belts that grind worlds into sand, or splinters from catastrophes that shattered whole systems. In holding them in the light, even briefly, we hold other histories. If this visitor is one of those, then the lesson is ancient and familiar. Worlds are made and unmade, and the debris roams. If it is not one of those, if it is a fragment of something crafted, then the lesson is vertiginous. We are not the sole authors of artifacts in this galaxy, and the sea between stars is salted with the leavings of others. The difference between those lessons is everything. The way to decide between them is the same as always. Look harder. There is a calendar of sky events that gives this story additional texture. In late this year and early next, the geometry of the inner system tightens into that near alignment already mentioned. The visitor threads that scene like an extra bead on a long wire. A few weeks before the alignment's peak, the object also brushes relatively near the Earth. Near only in astronomical terms, far beyond any hazard, but close enough to afford better photon budgets for our instruments. That pass is precious, proximity by signal, and signal by certainty. During that pass, if a massive coma exists, it should be unmistakable. An arc of particulate light hugging the path, a soft plume pointing away from the sun, structure within the tail hinting at rotation and jet source regions. If, contrariwise, the object is stark and clean and unhaloed, we will have to accept that either outgassing is not the driver, or that it operates in a regime that conceals itself almost perfectly. In either case, the acceleration data and the imaging data will have to be reconciled without hand-waving. Every solid conclusion in space science is a forced marriage between models and photons. There is also the possibility of fragmentation. Tidal stresses near perihelion, thermal gradients across weak points, spin up instabilities from jets. Each can crack a body. If fragments appear, their velocities and brightnesses, their survival or dispersal, their sudden flares or quiet fade, will speak about cohesive strength.
A rubble pile tells a different story than a monolith. A monolith tells a different story than a sheet. Fragmentation, while seemingly destructive, can be diagnostic in the way an anatomical dissection is diagnostic. You learn how a thing is built by seeing how it comes apart. Through all of this, it's tempting to narrate the visitor as a character with motives. It is not. It is a moving problem and a moving opportunity. It has no obligation to satisfy our curiosity or our narratives. It may glide away having taught us only that we needed better instruments and more patience, or it may force a revision in how we think small bodies can behave when they are made in other kilns than our own. Or, least likely yet not impossible, it may sit, stubbornly, outside the envelope of natural explanation long enough that we are compelled to admit we are looking at an artifact. Most surprises in astronomy end up being nature wearing a mask we haven't learned to recognize, but sometimes the surprise is genuinely new.
Imagine, for a final moment, the journey that led to this meeting. In some other system, under a smaller sun or a larger one, a disk of dust and gas flattened and spun. Grains collided, stuck, grew into pebbles, then boulders, then worlds. Somewhere in that dance, a piece was cast off by a violent shuffle of giants, by a near miss, by the casual cruelty of gravity. It sailed past the boundary of its natal light and entered the long night, where distances are measured in silence. For ages it drifted, past nebulae bright as bruises and clouds black as verdicts, until, by the simple arithmetic of straight lines and enormous times, it met our system and fell inward. And now we, who were not even minerals when it began, are here to catch its glint on our sensors and tilt our heads and ask what it is made of, how it moves, whether it is alone, what else like it may be passing by unremarked. We, who build our understanding one photon at a time, are ready to add these photons to the pile. The visitor does not care, the universe does not care, but caring is our art. We do it well. Soon it will come out from behind the sun. Soon the glare will ease. Soon the numbers will thicken and the plots will bend toward clarity. The answer may be ordinary, dressed in unexpected clothes. The answer may be extraordinary, waiting with patient audacity in the open field of possibility. Either way, we will go to where the answer lives, to the telescope, to the spectrum, to the math. The visitor will either wear a veil of its own making, or it will not. It will either carry a shove in vapor, or it will ride the push of light, or it will teach us a new shove we have not yet named. It will either be a shard of nature's doing, or it will be a shard of someone's making. Neither outcome diminishes the other. Both enlarge us, because each demands that we look with clearer eyes at a universe that is more inventive than our habits, more patient than our questions, and more generous than our fears. The object had now passed behind the sun and emerged once again into the open clarity of space, where light could fall upon it without interference. Its reappearance marked the beginning of a new phase of observation, one in which every measurement mattered, every subtle shift in brightness might contain meaning, every line of data could be a clue. For months leading up to this moment, astronomers, researchers, and patient skywatchers had anticipated this phase, not because they expected something dramatic to occur, but because this was the moment where explanation begins. The object had behaved strangely. It had accelerated without sufficient visible cause. It had refused the easy categorization of comet or asteroid or fragment. It had moved with the quiet defiance of something that does not quite fit the rules we know. Now, with the sun no longer blinding our instruments, the object's secrets could be approached directly. When the very first images captured it again, the object appeared faint, much fainter than during its approach. This was expected. It was further from the sun now, receiving less heat, producing less reflective brilliance. Yet its faintness alone did not speak to its nature. What mattered was what surrounded it. The question was simple. Did it have a large cloud of gas and dust around it or not? If it was losing mass at the rate required to explain its non-gravitational acceleration as outgassing recoil, then the space around it should now be blooming with material, glowing, scattering light, visible in even modest imaging.
But early measurements suggested something else. There was some dust, some gas, a faint haze, a thin halo, but nowhere near the mass that should exist if the object were shedding material at the predicted scale. This observation did not solve the mystery, it sharpened it. The absence of a dramatic coma suggested that the mechanism responsible for the object's acceleration was either much more subtle than typical cometary outgassing or not driven by outgassing at all. The object did not suddenly clarify itself. Instead, it offered the same behavior as before, only now in clearer visibility. It continued moving with the same small but persistent acceleration. It continued reflecting light in a pattern suggesting an irregular and possibly elongated form. It continued existing in the narrow region between known categories of object. Its secrets did not reveal themselves by dramatic gesture. They revealed themselves by the patient refusal to become ordinary. Many natural explanations remained feasible. In the complexities of physics and chemistry, subtle mechanisms often exist that appear implausible at first glance, yet are entirely real in practice. For instance, an object with a surface of extremely fine crystalline grains could release gas in slow, diffuse wafts that disperse before forming a tail or prominent atmosphere. Likewise, an object with porous internal channels could vent molecules without ejecting significant dust. Chemical compounds unfamiliar in our own solar system might sublimate differently, more gradually, more silently. The cosmos does not owe us behavior that is familiar. The universe is filled with processes we have never seen close enough to understand. And yet, the absence of dust at the required scale still mattered. It was not merely an oversight or misinterpretation. It was a contradiction, a refusal of the object to match the expected consequences of a classical explanation. The measurements continued. Spectral analysis was performed to examine the composition of both the object's surface and the gases around it. These observations revealed traces of volatile substances typical of icy bodies, but again in quantities insufficient to explain the observed acceleration through outgassing alone. To some researchers, this implied that sublimation was occurring, but at a scale that might be optimized, not chaotic. The object might have layers structured in such a way that gas was released smoothly and evenly, producing acceleration without the visible plume. If this was true, then the object's internal composition would be unlike the common cometary bodies formed within our own system. To study such a composition would be to study a fragment of chemistry that evolved under the light of another star. To hold, even indirectly, a piece of another planetary nursery is to access history older than our own. But while this line of reasoning held power, another line of reasoning also remained open. If the object were being pushed by light itself, solar radiation pressure, then its surface must be highly reflective or its mass unusually low. These conditions could arise naturally, but they could also arise in engineered materials. Could nature produce thin, broad-surfaced structures? Yes, under certain conditions. Could it produce hollow shells? Yes. Could it produce fragments that behave like sails? Yes. Yet there is a limit to how far natural explanations stretch before probability becomes strained.
and there is a limit to how far artificial explanations stretch before evidence must appear. For now, both remained on the table. As the object continued to move outward, attention shifted to what would soon follow: the planetary alignment. This alignment was not expected to affect the object directly in any dramatic way. Its gravitational influence on the system was minuscule compared to planets and the Sun. But its presence during the alignment created a unique opportunity. During such alignments, the magnetic behavior of the Sun sometimes shifts. Solar storms wax and wane. Charged particles ride along the solar wind toward planets. Auroras brighten. Radiostatic changes character. Instruments detect fluctuations in the invisible architecture of magnetic loops and plasma waves. And when these things change, they sometimes illuminate hidden properties of objects traveling in space. If the object interacts with charged particles, we may learn about its electrical characteristics. If its dust grains align with magnetic fields, we may learn about their size and composition. If its brightness changes during high-energy solar events, we may learn about the heat conductivity of its surface.
These are measurements, not dreams. They are the quiet mathematics of how objects speak to us without words. The alignment approached slowly, written in the steady turning of planets. And during that approach, the object continued outward, slowly dimming, but still within the reach of instruments that cared enough to watch. Parallel to these physical observations came something more philosophical, but no less real. Humanity has always looked up and wondered. Long before telescopes, before lenses, before formal science, there were questions. What moves through the heavens? Who else might be watching? Is the universe empty or full, or something between the two? These questions were not naive, they were inevitable. Now, for the first time in history, we possess instruments capable of answering such questions with something more than imagination. We no longer ask space to send myths, we ask it to send measurements. The object's refusal to behave like a familiar comet did not imply intention or intelligence, it simply implied difference. And difference is the beginning of learning. This is the threshold where curiosity becomes discipline, where wonder becomes method, where awe becomes analysis. The object is not extraordinary because it might be artificial. It is extraordinary because it is real, and it is here, and it does not match existing patterns without adjustment. It forces a re-examination of assumptions. And science progresses when assumptions are challenged, not when they are obeyed. The next step would come during the alignment, and after that, when the object faded into the deep twilight of the outer system, leaving behind only data. But the story did not end there. It deepened. As the object continued outward, its path took it through a region of space where sunlight grows weaker and shadows deepen. At these distances, the sun is no longer a blazing presence dominating the sky. Instead, it becomes a strong star among many, still ruling the local gravitational field, but no longer overwhelming in brightness. In such places, darkness is not absence, it is the default state. Light exists only where it is earned. Yet, even here, the object remained visible, faint but measurable, quiet but not silent. Observatories tracked its light curve, the subtle pattern of brightening and dimming as the object rotated. This pattern was not smooth or symmetrical. Instead, it displayed irregular peaks, uneven troughs, asymmetries that suggested a body whose shape was far from spherical. Such variations are expected in elongated or fractured objects, but the details contained nuance. The period of rotation was not chaotic, it repeated, though with slight deviations. These deviations implied a tumble, not the free, wild tumble of a loose, shapeless cluster of gravel, but the measured, consistent tumble of an object with internal rigidity, something holding itself together despite forces that could easily have shattered something weaker. It was, whatever its origin, cohesive. Objects that pass near the sun are often subjected to powerful tidal forces. Heat can fracture, stress can pull, gravity can tear. The fact that this visitor remained in one piece was notable, not unprecedented, but significant. Whatever material composed it, whatever bonds held it together, they endured. This endurance brought new questions. Was the object once part of something larger? Was it a fragment broken away long ago, cast adrift into the interstellar dark? Or was it formed as a small object from the beginning, shaped by a process unfamiliar to our own system? Our solar system's comets form in regions where ice and dust accumulate gradually. Over time, these materials fuse loosely, forming porous, fragile masses. Yet the object's structure suggested something more resilient, more tightly bound, possibly layered, possibly crystalline. There was a complexity that spoke of a colder environment, or a different one.
This led researchers to consider the nature of planetary systems beyond our own. Other stars have planets. Other stars have debris fields. Other stars have icy reservoirs. But the chemistry of those reservoirs is determined by conditions we cannot reproduce. Different stellar radiation, different temperatures, different proximities to heat, different mixtures of elements. A body formed elsewhere carries the signature of that elsewhere. The visitor could be a messenger, not in a metaphorical sense, in a literal sense, matter that originated under a different sun. If a person holds a meteorite in their hand, they hold a fragment of another world. If humanity measures this object, we measure the minerals and ices of a system we will never touch. Even if the visitor is completely natural, it is a gift of priceless scientific value. Yet, it is not simply its origin that intrigues, it is the way it moves. The acceleration that does not match typical cometary behavior continued as the object traveled outward. Measurements refined earlier models. The acceleration was consistent, small but consistent, waning slightly as distance increased. This hinted that the mechanism driving the acceleration was not dependent solely on sublimation of volatile materials. Sublimation decreases rapidly as sunlight weakens, therefore a different force must be contributing. One candidate remains central: solar radiation pressure. Light has momentum. When photons strike a surface and are reflected, they impart a tiny shove. For objects with extremely low mass relative to their surface area, this shove can become measurable. The thinner and lighter the object, the stronger the effect. If the visitor was naturally thin, perhaps a fractured sheet of carbon-based crystal, perhaps a flake of layered mineral, sunlight itself could be helping to propel it. Yet, if it were too thin, the object would not have survived perihelion. The sun's radiant heat would have destroyed it. It would have broken apart. It would have evaporated. The fact that it survived means its composition balances fragility with resilience, a difficult but not impossible balance. There are substances in the universe that behave like this. There are natural processes that produce sheet-like structures. There are minerals that fracture in planar forms. There are crystals that form in thin lattices. There are ices that shatter into flakes rather than dust grains. But such structures are rare, and rarity combined with interstellar origin naturally draws attention. However, it is important to emphasize, unusual is not the same as unnatural. Unfamiliar is not the same as artificial. Mysterious is not the same as intentional. The universe has had billions of years to invent processes we have not yet imagined. Still, there is a boundary where natural explanation becomes improbable enough that further scrutiny becomes necessary. The visitor now approaching that boundary. To cross that boundary responsibly requires discipline, not speculation, not shortcut conclusions, not narrative leaps, only evidence. More data was needed. And so, as the object continued outward, telescopes across the world tracked it nightly. Observatories monitored its brightness in multiple wavelengths: visible, infrared, ultraviolet. Polarimetry measured how light scattered across dust grains. Time series analysis mapped rotational periodicity. Out-of-plane motion was mapped precisely to track any changes in trajectory. Meanwhile, the planetary alignment approached, and with it, the Sun prepared to enter a phase of increased activity. During such phases, the Sun produces more flares, more coronal expulsions, more bursts of charged particles. These events travel outward and interact with everything in their path, including objects much smaller than planets. If the visitor's surface interacted with charged particles, it might brighten briefly. If it contained magnetic material, it might respond differently during disturbances. If it possessed dust grains susceptible to electric charge, they might align in structured patterns. Such effects can be seen only during times of heightened solar activity. The alignment, therefore, was not merely an astronomical curiosity. It was a lens, a magnifying glass through which the object could be studied more precisely. And there was another aspect to consider. While the alignment itself was a geometrical configuration, its symbolism was not trivial. Humans are pattern-seeking beings. We feel the significance of timing even when cause and coincidence are not linked. And here was a moment where the planets of the system drew themselves into formation, just as a visitor from outside the system passed among them. To dismiss the symbolic beauty of that alignment would be to ignore a profound element of human experience. Yet to ascribe meaning to it would be premature. Symbols are what humans build. Measurements are what nature gives. And yet, sometimes the two meet. As the alignment neared, more complex models of the object's movement were developed. Some models treated it as a comet. Others treated it as a reflective sheet. Others treated it as a layered, anisotropic solid with directionally selective sublimation patterns. Each model could match some features of the data, but none matched all of them. This is where science advances, not in certainty, but in tension, not in answers, but in the sharpening of questions. The object was becoming less mysterious, but also more interesting. It was no longer simply a curiosity, it was becoming a key to how matter behaves across interstellar distances, a key to how planetary systems distribute their debris, a key to how our assumptions guide our interpretation of the unknown. The visitor had emerged from the Sun's shadow. The alignment was approaching. The solar activity cycle was rising. The stage, whether by coincidence or by cosmic rhythm, was set. What would come next was not spectacle, it was revelation, slow, careful, incremental revelation, the kind that changes understanding quietly, the kind that lasts. As the object traveled farther from the Sun, its path took it into a region where sunlight, though weaker, still provided enough illumination for detailed measurement. At this distance, the contrast between the object and the darkness around it sharpened. It was now possible to examine it not as a bright, dynamic body near the Sun, but as a steady, faint visitor against the deep backdrop of space. This phase was critical. When an object moves away from a star after perihelion, any sublimation-driven outgassing should diminish sharply. The thermal energy drops, volatiles cool and stabilize, jets cease. The object should begin to follow a purely gravitational trajectory again. The acceleration that had puzzled researchers earlier should weaken, then fade. The object should settle into predictable motion, like any other inert body in deep space. But that is not what happened. The object continued to exhibit small but measurable non-gravitational acceleration. Not as strong as before, but stronger than expected given the cooling environment. And most importantly, the acceleration remained smooth. Natural outgassing is seldom smooth. It sputters, it pulses, it decays unevenly. Yet here, the push remained consistent, not perfect, not flawless, but steady, persistent, continuous. This was the detail that drew the most attention. Something was regulating the force acting on the object. Whether that regulation was inherent to the object's material composition or something more complex was still unknown. But regulation implies structure, and structure requires an origin. To some researchers, the implication was that the object might be composed of layers, thin, stacked sheets of material, each capable of shedding extremely fine molecules in a controlled manner, releasing gas slowly over large surface area, producing thrust without creating a visible coma. This could happen naturally under certain formation conditions. For instance, in environments where ices form microscopic plates rather than amorphous structures, sublimation can be uniform. Gas escapes evenly from across the entire exposed surface. No jets, no plumes, no sudden eruptions of dust. Just a gentle, even exhalation, like the slow release of breath on a window. Other researchers emphasized the radiation pressure explanation, that the object's acceleration could be explained by sunlight pushing on a thin reflective structure. In that case, the object would not need to be shedding mass at all. It would only need to be light enough, broad enough, or structured in such a way that photons provided the necessary momentum. But this explanation too demanded something specific. An unusually low mass relative to surface area.
Such a ratio occurs rarely in natural objects, yet not impossibly. Under certain conditions, a fragment of surface material from a larger parent body can break away in a sheet rather than a chunk. For example, a crust formed by pressure gradients or crystalline growth might fracture cleanly, leaving behind thin plates. If such fragments survived ejection into interstellar space, they could drift like leaves rather than stones. However, the thinner the object, the more fragile it should be. The closer it passes to the sun, the greater the thermal stress. The fact that this object endured perihelion intact suggests a composition capable of resisting high heat. This tension between fragility and resilience was becoming the defining feature of the visitor. And while this scientific investigation unfolded, the countdown to the planetary alignment continued. In the weeks before the alignment, the Sun entered a period of heightened magnetic turbulence. Dark, concentrated regions of twisted magnetic flux, sunspots, grew in both frequency and complexity. These regions often herald strong solar flares and coronal mass ejections. Charged particles began to pulse outward with greater regularity. It was during this rise in solar activity that the first significant observational opportunity occurred. A burst of charged particles from the Sun, harmless to the object but rich in diagnostic value, crossed the region of space where the visitor was traveling. When this happened, detectors observed a subtle shift in the polarization of light reflecting from the object. The shift was small, tiny, but meaningful. It suggested that the dust near the object was interacting with the charged particles. This implied that the dust grains were extremely fine, on the scale of microns or smaller, consistent with earlier hypotheses that the object, if shedding mass, was doing so in a form too fine to form a visible tail. But the polarization response was not random. It had structure and orientation. This suggested that the dust grains were not scattering randomly, but aligning, even briefly, with the incoming charged particle stream. Dust alignment indicates that the grains carry charge. Charged grains imply that interactions between the object and the solar wind are active. Active interaction suggests that the object is not inert. This was one of the first concrete clues pointing toward the object's physical behavior, not just its motion. While this was occurring, the alignment drew closer. As the alignment approached, something remarkable happened, not to the object, but to the system observing it. Human attention sharpened. New proposals were drafted. Observatories reassigned time to track the object. Researchers began looking not only for mass loss and reflectivity, but for electrostatic and magnetic signatures. Specialized models were run to examine how the object's rotation might shift under different influences. This shift was subtle but important. Earlier observations focused simply on fact-finding. What is the object? Now the focus was expanding. How does the object respond to its environment? This distinction is crucial. When we study a rock, we learn what it is. When we study its response, we learn what it does. And when we learn what it does, we learn what it is for. Not in the sense of intention, but in the sense of function. Everything in the universe has behavior. Even silence is behavior. Even stillness is information. The object was no longer just a shape traveling along a path. It was a participant in a system, moving, responding, reflecting, releasing, aligning. It was not passive. Meanwhile, conversations surrounding the alignment continued, not in terms of mysticism, but in terms of system dynamics. When planets align, their combined gravitational and magnetic influences shift the behavior of the solar wind and interplanetary magnetic field. These changes ripple outward. They shape the motion of charged particles. They influence auroras. They can even destabilize or intensify solar events.
This led researchers to consider the nature of planetary systems beyond our own. Other stars have planets. Other stars have debris fields. Other stars have icy reservoirs. But the chemistry of those reservoirs is determined by conditions we cannot reproduce. Different stellar radiation, different temperatures, different proximities to heat, different mixtures of elements. A body formed elsewhere carries the signature of that elsewhere. The visitor could be a messenger, not in a metaphorical sense, in a literal sense, matter that originated under a different sun. If a person holds a meteorite in their hand, they hold a fragment of another world. If humanity measures this object, we measure the minerals and ices of a system we will never touch. Even if the visitor is completely natural, it is a gift of priceless scientific value. Yet, it is not simply its origin that intrigues, it is the way it moves. The acceleration that does not match typical cometary behavior continued as the object traveled outward. Measurements refined earlier models. The acceleration was consistent, small but consistent, waning slightly as distance increased. This hinted that the mechanism driving the acceleration was not dependent solely on sublimation of volatile materials. Sublimation decreases rapidly as sunlight weakens, therefore a different force must be contributing. One candidate remains central: solar radiation pressure. Light has momentum. When photons strike a surface and are reflected, they impart a tiny shove. For objects with extremely low mass relative to their surface area, this shove can become measurable. The thinner and lighter the object, the stronger the effect. If the visitor was naturally thin, perhaps a fractured sheet of carbon-based crystal, perhaps a flake of layered mineral, sunlight itself could be helping to propel it. Yet, if it were too thin, the object would not have survived perihelion. The sun's radiant heat would have destroyed it. It would have broken apart.
it would have evaporated. The fact that it survived means its composition balances fragility with resilience, a difficult but not impossible balance. There are substances in the universe that behave like this. There are natural processes that produce sheet-like structures. There are minerals that fracture in planar forms. There are crystals that form in thin lattices. There are ices that shatter into flakes rather than dust grains. But such structures are rare, and rarity combined with interstellar origin naturally draws attention. However, it is important to emphasize, unusual is not the same as unnatural. Unfamiliar is not the same as artificial. Mysterious is not the same as intentional. The universe has had billions of years to invent processes we have not yet imagined. Still, there is a boundary where natural explanation becomes improbable enough that further scrutiny becomes necessary. The visitor now approaching that boundary. To cross that boundary responsibly requires discipline, not speculation, not shortcut conclusions, not narrative leaps, only evidence. More data was needed. And so, as the object continued outward, telescopes across the world tracked it nightly. Observatories monitored its brightness in multiple wavelengths, visible, infrared, ultraviolet. Polarimetry measured how light scattered across dust grains. Time series analysis mapped rotational periodicity. Out-of-plane motion was mapped precisely to track any changes in trajectory. Meanwhile, the planetary alignment approached, and with it, the Sun prepared to enter a phase of increased activity. During such phases, the Sun produces more flares, more coronal expulsions, more bursts of charged particles. These events travel outward and interact with everything in their path, including objects much smaller than planets. If the visitor's surface interacted with charged particles, it might brighten briefly. If it contained magnetic material, it might respond differently during disturbances. If it possessed dust grains susceptible to electric charge, they might align in structured patterns. Such effects can be seen only during times of heightened solar activity. The alignment, therefore, was not merely an astronomical curiosity, it was a lens, a magnifying glass through which the object could be studied more precisely. And there was another aspect to consider. While the alignment itself was a geometrical configuration, its symbolism was not trivial. Humans are pattern-seeking beings. We feel the significance of timing even when cause and coincidence are not linked. And here was a moment where the planets of the system drew themselves into formation, just as a visitor from outside the system passed among them. To dismiss the symbolic beauty of that alignment would be to ignore a profound element of human experience. Yet to ascribe meaning to it would be premature.
Not because of intention, not because of destiny, but because motion, when allowed enough time, can create meetings that would otherwise seem impossible. There is beauty in that. As the object traveled farther, the brightness of the Sun became weak enough that it resembled more closely the light of a distant star. The planets themselves receded into points of light. The warm familiarity of Earth vanished entirely. And still the object moved, continuing into a realm where only the few largest worlds would remain visible, pale circles drifting through immensity. It is important to understand that the object is not guided. It does not choose. It does not know. It simply moves along the path assigned to it by circumstances so old they are now beyond memory. And yet, its movement becomes meaningful to those who watch. There is a quiet idea in astronomy that the universe reveals itself only to those who are willing to see, not in the sense of mystical revelation, but in patience, in the willingness to observe without forcing the universe to match our expectations. This object did not announce itself. It did not ask to be studied.
It simply existed. And by watching it, humanity learned to notice the small deviations, the quiet details, the things that lie at the edge of perception. Some discoveries in science arrive through shock, bright explosions, loud events, dramatic transformations. But many of the most important discoveries arrive through quiet resistance. The universe whispers before it speaks. This object is such a whisper. Its refusal to behave like a familiar comet was not loud. It did not flare. It did not rip apart. It did not signal. It simply did not match. That quiet difference became the source of inquiry. That subtle mismatch became the question. It is often like this. Progress begins not when reality agrees with our assumptions, but when it refuses to. In this way, the object became a teacher. It taught patience. It taught humility. It taught awareness. It asked us to consider the possibility that matter formed under a different star may not behave as matter formed under our own. It suggested that universality is not uniformity, that the cosmos is consistent but not repetitive, that worlds can evolve differently, that chemistry can express itself differently, that structures can emerge from physical conditions we have not yet studied closely enough to predict. In its silence, the object asked, "How large is your imagination? How disciplined is your observation? How open is your understanding of nature?" Meanwhile, back in the inner system, the alignment of the planets drew into near completion. The orbits that had taken years to arrange now formed a configuration where one could draw a nearly straight line through several worlds and through the sun itself. To the human eye, looking from Earth, the planets still scattered across the sky, but the geometry in space was real. The alignment did not create meaning. We did. But the alignment did create perspective. It showed us that systems are not merely collections of independent spheres. They are structured relationships, moving, interacting, resonating across time. The visitor traveled among those relationships, not at their scale, not at their speed, but within their architecture. It crossed the plane upon which the worlds circle the sun. It moved through open corridors of celestial mechanics. It passed through space shaped by the interplay of gravitational balances. It was a guest, not because the system invited it, not because we welcomed it, but because hospitality, in the cosmic sense, is simply the absence of exclusion. Space permits passage. Gravity writes trajectories. Light reveals existence. Time carries everything forward. In the quiet of this region beyond the inner worlds, the visitor continued, and as it moved, the weight of human curiosity followed it, not to possess, not to control, but to understand. Because understanding is the one form of presence we can extend across the void. When we study a thing, we meet it. When we recognize a pattern, we connect with it. When we learn, we expand into the universe just a little more. The visitor was not ours. It did not belong to us, but our attention became a bridge to it. In the vast emptiness between stars, every bridge matters.
The alignment approached its moment of greatest precision. From the inner system, the worlds did not suddenly form a line visible to the human eye, but their gravitational and magnetic positions arranged into a pattern of unusual coherence. The sun, at the center, continued to generate its endless waves of light and plasma. Yet during alignments such as this, the behavior of its surface can shift. Fields may twist more tightly, eruptions of energy may become more synchronized, patterns normally lost in turbulence may become clearer. It was not that the planets commanded the sun, it was that the sun responded to the architecture of its system in ways still not fully understood.
And while these large relationships unfolded, the visitor continued its motion, unaware of the attention, the questions, the meaning placed upon it. It simply traveled. But for the observers who watched it across nights and months, this was a moment when patience and perseverance began to converge. The available data grew richer, not because the object had changed dramatically, but because every small measurement accumulated into a larger picture. The faint surrounding haze of gas and dust, the coma, was still present but remained subtle, enough to confirm that material was indeed leaving the surface, not enough to create a sweeping tail that could be seen easily. At first, this seemed contradictory, but this contradiction was slowly dissolving. The dust grains detected around the object were extremely small, almost powder-like. Such grains scatter light weakly. They disperse quickly. They are easily ionized and carried by the solar wind. In such cases, a visible tail never forms, not because mass loss is absent, but because the particles are too fine to reflect light strongly. This meant that the object could be losing mass continuously, consistently, and quietly, its acceleration powered by a mechanism that produced no grand display. In that realization, the object became less of a mystery in one sense, but more profound in another. Because the way the object loses mass, slowly, delicately, evenly, is not typical of the cometary bodies we know. This behavior suggests a surface composed of extremely fine crystalline layers, microscopic pores allowing slow, consistent sublimation, a structure that releases material like vapor through cloth, not through jets. This structure may have formed in an environment where temperatures changed very gradually, where matter condensed not in violent bursts, but in long, slow cooling under conditions unknown in our own system. Perhaps in the outskirts of another star's protoplanetary disk, perhaps in the quiet shadow of a world that no longer exists, perhaps in a region of space where dust accumulated in stillness, not turbulence. The object does not need to be artificial to be extraordinary. Nature, given time, can construct wonders we have not yet imagined. Yet the object's behavior under solar radiation still hinted at something more. The way sunlight pressure influenced its motion was not simply a passive push. It seemed to interact in a way that suggested the surface was not uniform. Some regions reflected more strongly than others. Some absorbed light. Some scattered it. This pattern was not random. This suggested complexity, not necessarily intelligence, but history. The surface of a body that has traveled through interstellar space is shaped by collisions so small they are invisible, but so numerous they sculpt the terrain. Microscopic particles striking the surface at high speed, one by one, for millions of years, sand the material into new forms. Radiation darkens portions, while impacts brighten others. Temperature cycling cracks surfaces, then seals them. What results is not chaos, but memory. The object's surface was a record of cold, a record of time, a record of silence. One could imagine it traveling through the galactic night, passing nebulae blooming like cosmic flowers, drifting through currents of dust illuminated by distant dying stars. It experienced no witness, it had no purpose, yet it carried the signature of all it had survived. The alignment provided a new window to examine that signature. As the sun's activity increased, subtle changes in the object's brightness were recorded. Not sudden changes, not dramatic changes, but variations consistent with the fine dust around it responding to charged particles. This interaction did not reveal intention, it revealed sensitivity.
The visitor was not merely reflecting light.
It was interacting with light. It was not merely pushed by solar wind, it was shaped, even slightly, by the invisible currents flowing from the star. This realization brought observers to a deeper understanding. The object was not simply in space, it was part of space. It responded to the environment it traveled through. This may sound obvious, but it is a profound truth. We often imagine objects in space as isolated, alone, independent. But nothing in the cosmos is separate. Everything is connected through fields of gravity, heat, charge, motion. The visitor reminded us of that continuity. As the alignment reached its peak, the object continued outward, its path now taking it gradually above the plane of the planetary orbits. The worlds of the solar system remained behind, arranged temporarily in their elegant line. Earth, small and imperfect, continued its rotation, unaware of how tiny it appeared in the geometry of the sky. The visitor, meanwhile, entered a region where distance began to soften measurement. It grew fainter, harder to track. Observations required longer exposure times, more careful calibration, more patience. The brightness curve flattened, the dust halo thinned. The signature of sublimation fell below detectable thresholds. The object was becoming quiet again. It was returning to the kind of silence that defined most of its existence. But the silence was not emptiness, it was completion. This phase was like the final chord of a piece of music that had played for months, quiet, steady, inevitable. The object had shown what it could show. The measurements had been taken. The models would continue to refine. But the visitor itself did not need to remain visible in order to continue teaching. There is a moment in astronomy when the object disappears, but the understanding remains. The object did not fade into darkness as something lost. It faded into darkness as something given. What remains now is not just data, it is perspective. It is the widening of what we believe is possible. The visitor did not shout, it whispered. And in that whisper, it carried the voice of the universe. There is more than you have seen. There is more than you have imagined. There is more than you yet understand. The object continued into the outer dark, not gone, just beyond. As the visitor continued outward, the solar system slowly receded behind it. The worlds that shone brightly during its passage grew faint, their orbits diminishing into distant circles of reflected sunlight. The sun itself became smaller once more, a warm star, not a dominating presence. The object had returned to the state in which it spent almost the entirety of its existence, alone, silent, drifting. But something had changed. Not in the object, but in us. Before its arrival, our understanding of interstellar matter was largely theoretical. We knew such objects must exist. We knew fragments could escape from distant systems, but knowledge without experience remains abstract, and abstract knowledge rarely transforms us. It is only when something becomes real, seen, measured, followed, that it gains weight in consciousness. The visitor made the galaxy feel closer. It made the space between stars feel less empty. It made the ancient paths of drifting matter feel familiar, perhaps even intimate. This shift is subtle but profound. The universe no longer seems like a remote expanse of unreachable distances. It appears instead as a network of pathways, slow, ancient, patient pathways along which countless objects travel across eons. The visitor was one such traveler. It is very likely that others are passing even now,
moving too faintly to be detected, gliding silently through the shadows outside our awareness. Perhaps some have passed before, perhaps many, but detection requires attention. Mystery requires curiosity. Understanding requires willingness. In recognizing this visitor, humanity demonstrated something remarkable. We are paying attention.
We're watching the sky, not out of fear or myth, but out of a desire to understand. This desire is one of the defining traits of our species. We are beings who look outward. We are beings who ask questions. We are beings who want to know what lies beyond the horizon, even when the horizon stretches across light years. The visitor was not large. It was not dramatic. It did not blaze across the night sky or disrupt the order of planets. Yet it carried the immensity of time. The atoms within it were forged in stars older than ours. The processes that shaped it took place before human language existed. The journey it has taken is longer than every story humanity has ever told. To encounter such an object is to be reminded of scale. Our lives are brief. Our accomplishments are recent. Our presence in the universe is new. Yet, we are capable of recognizing something ancient, and in that recognition, the ancient and the new meet. The object continued onward, following a path that would eventually take it beyond the boundary where the sun's gravity fades into the subtle tug of the galaxy. It would not escape the galaxy's influence, few things do, but it would drift once more among the long currents of interstellar space, carried by no force except the ones that govern everything: motion, inertia, time. In a way, the visitor's journey is not extraordinary at all. It is simply a consequence of physics and patience. A piece of matter in motion will continue in motion unless acted upon. Here, nothing acted strongly enough to stop it. And in another way, its journey is entirely extraordinary. For in a universe of unimaginable size, the odds that this object would cross paths with a species capable of observing it, a species that had developed mathematics, optics, and the ability to reflect, are staggeringly small. And yet, here we are. Two travelers, one made of ancient ice and dust, the other made of thought, curiosity, and memory, meeting for a moment in cosmic time. The visitor will not remember the encounter, but we will. We will remember that an object older than our species passed our system. We will remember how it defied simple categorization. We will remember that nature is not obligated to conform to familiar forms. We will remember that understanding the universe requires openness, patience, and humility. The object may never return. The probability of a second passage is vanishingly small. Its path will take it outward, away from us, into a region from which communication, if communication were possible, would take centuries. But its presence has already changed the way we see. We now understand that interstellar objects are not rare, they are inevitable. They are part of the galaxy's circulatory system, its slow, ancient heartbeat. Fragments of worlds, messages of possibility, particles of time. We're watching the sky, not out of fear or myth, but out of a desire to understand. This desire is one of the defining traits of our species. We are beings who look outward. We are beings who ask questions. We are beings who want to know what lies beyond the horizon, even when the horizon stretches across light years. The visitor was not large. It was not dramatic. It did not blaze across the night sky or disrupt the order of planets. Yet it carried the immensity of time. The atoms within it were forged in stars older than ours. The processes that shaped it took place before human language existed. The journey it has taken is longer than every story humanity has ever told. To encounter such an object is to be reminded of scale. Our lives are brief, our accomplishments are recent, our presence in the universe is new. Yet we are capable of recognizing something ancient, and in that recognition, the ancient and the new meet. The object continued onward, following a path that would eventually take it beyond the boundary where the sun's gravity fades into the subtle tug of the galaxy. It would not escape the galaxy's influence, few things do, but it would drift once more among the long currents of interstellar space, carried by no force except the ones that govern everything: motion, inertia, time. In a way, the visitor's journey is not extraordinary at all. It is simply a consequence of physics and patience. A piece of matter in motion will continue in motion unless acted upon. Here, nothing acted strongly enough to stop it. And in another way, its journey is entirely extraordinary. For in a universe of unimaginable size, the odds that this object would cross paths with a species capable of observing it, a species that had developed mathematics, optics, and the ability to reflect, are staggeringly small. And yet, here we are. Two travelers, one made of ancient ice and dust, the other made of thought, curiosity, and memory, meeting for a moment in cosmic time. The visitor will not remember the encounter, but we will. We will remember that an object older than our species passed our system. We will remember how it defied simple categorization. We will remember that nature is not obligated to conform to familiar forms. We will remember that understanding the universe requires openness, patience, and humility. The object may never return. The probability of a second passage is vanishingly small. Its path will take it outward, away from us, into a region from which communication, if communication were possible, would take centuries. But its presence has already changed the way we see. We now understand that interstellar objects are not rare, they are inevitable. They are part of the galaxy's circulatory system, its slow, ancient heartbeat. Fragments of worlds, messages of possibility, particles of time.